Guys, my name is Zvendiya. I'm going to prove beta in matrix form. Then here is the model given matrix form. Y is a vector of dependent variables, x is a vector of independent variables, and beta is a vector of parameters, e is a vector of residuals. And here our estimated value of y is equals to x beta 8, where our error is equals to y minus x beta 8. Then finding the value of beta 8 in matrix form involves minimizing the squares of our residuals. So in this case, the squares of residuals will be given in the following form. So it's E transpose multiplied by E, which is equal to our y minus x beta 8 transpose multiplied by y minus x beta 8, like this. So first of all, by expanding this, we get then y, then affected by a transpose multiplied by y there, we get y transpose y. Then x beta multiplied by y, then also y multiplying by x beta, we get 2x transpose y. Then generally, if we multiply the betas, we will get our beta 8 there. Then minus and a minus, then multiplied by x beta transpose multiplied by x beta transpose, we will get plus beta 8 x transpose, then x beta 8, which will be equal to our squares of residuals. Right, then our squares of residuals will be a sum there. Then in this case, we are going to minimize the sum of squared errors by taking the first derivative with respect to our parameter beta. So the first derivative is equals to E transpose E over the first derivative with respect to our parameter beta, which is equals to, then in this case here we're going to have beta, so it actually converges to 0. Then here, if we find the first derivative with respect to beta, it's negative 2x transpose of y plus here, if we find the first derivative with respect to beta, it's 2 right beta 8, then here we get x transpose of x. Then by minimizing, we are equating this to 0. Then taking this minus 2x transpose y to that side, we get 2 beta 8 x prime x equal to 2x transpose of y. Then here, multiplying both sides by 2, generally we will get this result. Therefore, in order to get rid of this x transpose x, we have to multiply both sides by the transpose, so that when an inverse is multiplied by the original matrix, it will converge to an identity. So we are saying our beta 8, which is a constant or a column of parameters multiplied by x prime x inverse multiplied by x transpose by x, we will get, then multiplying both sides, then that's x as the inverse there, multiplied by the transpose of x multiplied by y. So here we will get beta 8 multiplied by the identity, which is equals to x prime x to the power negative 1, meaning an inverse multiplied by the transpose. So whenever a certain matrix is multiplied by an identity, it remains the same matrix. So here we will get our beta 8 equal to x prime by in inverse multiplied by x transpose of y. And this is actually our beta, which is a column vector of parameters. Thank you guys, until we meet next time.